Okay, so welcome to my channel. So in this video I'm going to explain the concept of um, open relative but this topic comes under the compact sets, where we deal with compact sets, and in here we deal with in compact sets we have open covers and subcovers, and in subcovers we have finite intersection property, and also there are some other topics that is considered to be included in the concept in the topic compact sets. Now we are having the first concept in compact set is open relative. When we call open relative, when there is a set E in Y, there is a point belongs to E, which is having a neighborhood X, which is inside Y. So at that time we can say that E is said to be open relative to Y. That's it. Alright, now there is a theorem related to this, only one theorem. Suppose Y is a subset of X. We know that Y is not just drawn over here. There will always be a X over here. Alright, so Y is a subset of X. A subset E of Y, the subset E of Y is open relative to Y if and only if E is equal to Y intersection G for some open set G in X. So basically what it's saying that there is a metric space. We know that Y is a subset of X. Alright, this is XG. Right, then we have Y, then there is a subset E. This one is E. There are some open sets, open neighborhoods. We consider the GIs, that is equal to union of open sets. In this case, where I'm considering with SP. Alright, and E, we are getting E by Y intersection G. How we get this? There are some open sets in Y and there are some open sets G in X. We are getting this E by intersection G. Open sets of Y belonging to Y and open sets belonging to G. When we are intersecting these two, we are getting E. For example, the open sets will be here as well. Alright, so this is pretty much Y intersection G. Now for precise explanation here, like let take a point P belongs to E. So there exists a neighborhood endo P of P. Alright, endo P of P, which is a subset of or equal to E. Alright, we're considering point P over here, P, with the neighborhood endo P. Alright, in here, which is a subset or equal to E. If I consider that G equal to union of SPs, P belongs to E. Now this union of SPs means a set that we are considering that is X belongs to X, such that distance from X to P is less than dou P. Now we have considered a set SP. Alright, here one more thing that I want to add: the points which are exactly inside E belonging to E, we consider that sets are SP, but the points which are outside these neighborhoods, open sets, are considered to be G. Alright, so there is no doubt in it. There should not be any doubt. So we are considering a set SP, which is inside dou P. Means you are considering a point P, and you are drawing a neighbor of that. You are considering the point P and you have drawn a neighbor of that. Alright, should I draw it over here? I'm zooming this out. Zooming this in. We have P with radius dou P. All right, so we are saying that SP are the set of SP is a set which is at the distance from X to P, which is at the distance from X to P. Previously we have considered that is a point X to P. Wait a minute. This is, we have E, this is point X, this is point P. So basically the distance from X to P will be it is a neighborhood of P. Actually it is not a correct circle, you have to draw it clearly like this. This is the actual drawing with the radius of P equal to dou P. Now we are considering a point X which is belonging to this P. Alright, we get that XP is less than dou P, hence we can consider that X belongs to this dou P. Now we can say that let G is equal to union of SP's P belongs to E. Alright, we get that union of E. Now we know we have to prove. Now we have to prove E equal to Y intersection G. Alright, since we know that P belongs to E and P belongs to G, you know that, and P also belongs to Y, that implies P belongs to SP's, this set. From there we can write P belongs to union of SP's intersection Y. The sets, the open sets or the neighborhoods that which are intersecting with Y, we are considering that as a point P. Now from there we can write P belongs to G intersection Y, and from there we can conclude that E is a subset of G intersection Y. Now conversely, we are assuming that a point Q belongs to Y intersection G. So that means from that we can conclude that, I'm writing over here, from there we can write Q belongs to Y and Q belongs to G. But we know that G can be written as union of SP's. Alright, here we have Q belongs to Y. Since we get union G is equal to union of SP's. Now from there we can write distance from Q to P is less than dou P, since it is belonging in Y, and Y can be written as, that is what we have written. Sorry, I have not written, maybe. So Y is basically, you can write Y as okay, we have okay, sorry for that. Distance from Q to P which is less than dou P. P, that is, we have already taken a point belongs to Y, and we are getting the neighborhood of Q is less than which belongs to this dou P. So from there we can write Q belongs to E. From there we can write Y intersection G is a subset of E. From this and this we get that E equal to Y intersection of G. Alright, and also we can use, and also to explain this problem we can use open relative concept. All right, that is E is equal to y intersection G. We know that is G belongs to X. Open sets G are nothing but open sets. Now we are saying that there is a P. There is P belongs to E. That implies P belongs to G. All right, since it's of open sets in X, then neighborhood of P is SP, such that this is a subset of G. G is in X. SP intersection Y is a subset of G intersection Y. Since SP is a subset of G, we get that G intersection Y here. And G intersection Y is a subset of E, that is we already got. And SP intersection Y we got. Since distance from from there we get that SP intersection Y. From there we can conclude that there is a point Q belongs to Y and SP, such that distance from P comma Q is less than dou of dou, that is the radius of SP. Hence we can conclude that this Q belongs to Y, Q belongs to this G, and from that we can conclude that this SP is since it is, these both are subset of E, since we can conclude that this SP is open, E is open relative to Y, and that E is okay.